The Mitre attack framework is one of the most successful projects from Mitre and actually very popular in the industry. I am a big fan of the Mitre attack framework because it provides a set of matrices of the tactics and techniques that real-life attackers, use to perform many different attacks and, of course, impact to many different organizations. Now, this is a collection of matrices, right? And there's several of them, as you see here. There's the matrix for enterprise, which is actually the most popular. Within it, there's different matrix, one for Windows, the pre-attack, but it's actually combined with reconnaissance, and we'll get to that in a second. But you have one for Windows, one for Mac, one for Linux, one for cloud, and also one for network. And as a matter of fact, I contributed to the network matrix and specifically, some real-life attacks that we have actually observed against network infrastructure devices, right? But there's one for mobile, one for ICS as well, for industrial control systems. Now, if I go back to the main page, right, I think it shows a little bit better all the different tactics and techniques. So you see different areas of the life cycle of an attack, from reconnaissance all the way to impact, right? And that includes basically the day in the life of an attack. From the moment that an attacker is trying to gather information from its victim, all the way to command and control, exfiltration, and of course the overall impact to the organization. One of the cool things that I like about the Mitre attack framework is that they provide an amazing set of resources for you to get familiar with, these different tactics and techniques, whether you are in the defensive side, so you're an incident responder in a security operations center, or whether you are in the ethical hacking or offensive security. This provides you with basically a real-life description and examples of the techniques and tactics that attackers actually have used. For example, let's go over privilege escalation, right? So you have the description and you have different techniques. Within those techniques, there's different sub-techniques related to that activity, right? So for example, for privilege escalation, you see that the ID for the main technique, and then you have .001. That's a sub-technique. And in this case, it's actually setting the UID and set UID and set group ID for a Linux environment to abuse that configuration to perform privilege escalation. And the other cool thing that they actually have is that they give you even the commands that have been used. In this case, is really, really simple, right? But the commands that have been used by attackers and adversaries to perform these tactics and techniques, right? It also provides with very detailed information about the different examples and basically real-life attacks. If it is in the Mitre attack framework, it is a given that will be a real-life confirmed attack, right? And in the bottom of each of their pages, they actually have different references that go over whether it's an article about a breach or some blog post from a technical person describing the attack, or things that are already in the public domain, right? Let's click on another one, like defense evasion, for example. In this one, you actually see a whole bunch of other sub-techniques, right, within the defense evasion category or defense evasion technique. And if you click on like token impersonation and theft, right, you also see different true real-life examples, right? And if you go over any of the other ones, you see, again, different examples on how you can perform this adversarial technique, right? In the case of adversarial emulation, what a lot of people actually call some of the activities of the purple team, right? So you know that the blue team is the defensive side, the red team is the offensive side. So it's kind of a hybrid between both into the way that you can absolutely take advantage of these resources to potentially perform automated adversarial emulation. And we'll get to that in a second. There's actually even different tools that also the community and Mitre have created to perform those type of emulations. As you see here, these procedural examples are basically real-life attackers, right? Or types of malware or types of tools that actually use this type of techniques, right? Now, if you actually see any of these sub-techniques and descriptions and so on, yes, you can absolutely take advantage of it to learn. So absolutely, that's, I have done it and I suggest for people to do. However, this goes beyond learning. What a lot of companies have done is that they have integrated the MITRE ATT&CK framework within their tools. So if there's a detection, for example, or some type of alert, it actually can be mapped to the specific tactic and techniques from the adversary. So then you can, perform additional things. It can help you in threat hunting. It can help you in other areas within the Security Operations Center itself, right? Now, if you go under resources, there are a few things in here. They have from things on how to get started with the attack framework, training, that have provided for free. AttackCon is a conference that they have in an annual basis, and they have tons and tons of presentations. As a matter of fact, if you actually click in here, of course, you see different presentations that are there. But if you go all the way to the related projects, there are a few things that are related to the MITRE ATT&CK ecosystem, if you will, right? There's a GitHub repository. Within the framework, there are different tools that allow you to illustrate and navigate to the framework, and one of them is actually called the Attack Navigator, and we'll get into that in a second. I'll show you an example. And then you have related formats. So in other words, if you actually have a specific observable or a specific technique, the community, and specifically MITRE, with the CTI community, and CTI stands for Cyber Threat Intelligence, they have created an express attack in STIX format. And STIX stands for the Structure, Threat Information Expression. As you see here, is basically a language to share threat intelligence. And you will learn this throughout the course in here. And it's basically, that is a machine-readable format. And in that case, it's a JSON format that you can use, of course, to exchange threat intelligence, information among participants. And specifically, if you want to share things related to the tactics and techniques of an attack, that's where, the integration of the attack framework expressed in STIX comes into play. Now, another thing in this page that I want to draw your attention is a tool called Caldera. And it's an automated adversary elimination tool that basically you can use with a whole bunch of different plugins to basically simulate what an attacker can do, and is completely mapped to the attack framework. There's another ecosystem underneath called the Atomic Red Team. I'm not going to go into a lot of that detail for the scope of this course. However, these are tools that I highly recommend for you to actually, learn and explore. And specifically, if you're looking into a career as an analyst, whether it's a junior or a senior analyst in a security operations center. Now, if I go back to the framework and I click on software here, this is a list of different either pieces of malware or legitimate software that has been used by attackers to perform, different types of activities, right? And this can be things, for example, let me actually go back to the letter C and look for CobbleStrike. CobbleStrike is a commercial adversarial emulation / pen testing / red teaming tool, right? It actually has been used by many Fortune 500 companies and government institutions. However, attackers have also taken advantage of these tools to perform a plethora of different attacks. And if you see here, it's a very extensive list of all the different tactics and techniques that you can basically emulate with that tool, right? So I picked this one because it's a little bit controversial in the security world because, the dual use of that tool, right? Now, I wanted to take advantage of this screen and basically show you the Attack Navigator, right? And just like we are right now, we're under software and CobbleStrike. I'm going to click on the Attack Navigator, and you can do two things. You can download this information in a machine-readable format that then you can actually, basically in JSON, that you can then import to a local, instance of the Attack Navigator, or you can click on View, and that actually, will take you to MITRE's, hosted Attack Navigator. And as you can see, it says, CobbleStrike, which is the name of the software that we selected. And again, this is just one example out of many, many different things that you can actually do with a framework, or at least show in the navigator and navigate, for, no pun intended, for all the different tactics and techniques. And every single one that are related to, in this case, CobbleStrike, are being highlighted. Now, the cool thing about this one is that you see some comments. If I hover over these elements, you can absolutely create your own comments and so on. For example, I can highlight this parent pit spoofing, and I can add a comment in there, right? Either modify it or add, this was observed in my investigation, right? And, this is, of course, a very lame example, but, you get the point. Basically, you can actually put any type of comments. And what is actually useful is because you can exchange this information in machine-readable format. And again, a lot of commercial tools already integrate the attack framework and the elements that you get from the navigator within their tools. And Cisco is actually one of them, right? So if you download that, you can see that I'm able to download it in machine-readable format, in this case, and it's a JSON file that has all the different elements about the observer, all the techniques and tactics that CobbleStrike is actually doing. So this is a view from a software perspective. You can also do the same thing as a view from the specific tactics, or map whatever emulation you're trying to do, or whatever type of threat hunting activity that you would like to do. You can absolutely do the same. Now, as I mentioned, there's different commercial tools that take advantage of the attack framework. Pretty good example of it, of course, part of the SecureX ecosystem at Cisco within ThreatGrid. And you learn that ThreatGrid is basically a sandboxing, and actually goes beyond sandboxing, but a behavior analysis and sandboxing solution from Cisco that is integrated in many, many different other platforms, right? Like AMP4 endpoints, Firepower Threat Defense, and many others, right? But basically, as you see here, they have the mapping of the attack framework in different behavioral indicators that I'm showing in the screen. So in this case, actually, the second one that you see says excessive remote process code injection detected. And there are two techniques from the Mitre attack framework: defense evasion and previous escalation. If you click on that, you will actually see related activity to the same behavior. Basically, it's a tag that shows you other types of activities within the network. And as you can see, this is a demo system, but it has a lot of different types of attacks, right? That actually, include defense evasion. The same thing if you want to go and see previous escalation, right? There's a lot of different techniques that also have been detected that are related to previous escalation, right? Scheduled task and, registry entries actually being detected that may be modified and so on. And as you can see, if I expand one of these, it has a direct reference to the Mitre attack framework. So again, for the purpose of this exam and for the purpose of this course, this is all what you need to actually know. You don't need to actually configure and, go deep. The concentration exams and the CCIE lab absolutely will test you into the very, details of the configuration and troubleshooting of each of these devices and solutions. Cybersecurity forensics, or digital forensics, has been a growing interest among many organizations and individuals. And this is due to the large number of breaches during the last few years, right? So many folks choose digital forensics as a career path in law enforcement and corporate investigations as well. So during the last few years, there have been an advent of many technologies and forensics processes that are designed to meet the growing number of cases relying on digital evidence, right? So there's a shortage of well-trained, experienced personnel that are experts in cybersecurity forensics. Cybersecurity forensics practitioners are at a crossroads in terms of changes affecting evidence recovery and also management. Forensics evidence is actually used to be brought into courts, right? The courts of law. And this is why it is extremely important for digital forensics experts to collect and maintain reliable evidence and a good analysis that is actually done of their findings, right? So also there's a huge increase in cybercrime that has increased the need for enhanced information security management, right? So it also requires forensics experts to help remediate the network and affected systems, and also try to reveal who was the responsible threat actor, right? So this is actually often called threat actor attribution. Now, desktops, laptops, mobile devices, servers, firewall logs, any type of logs from network infrastructure devices are rich in information of evidentiary, so that can be value for evidence that can assist forensics experts in reconstructing the attack and also gaining an understanding on the threat actor responsible for the attack. There are three categories for cybersecurity investigations. The first one is public investigations, which is actually resolved in the court of law. The second one is private investigation, which corporate investigations is an example of. And then also individual, which is actually often in the form of e-discovery. In addition to cybercrime and cyber attacks, evidence found on a system or in a network in this case may actually be presented in a court of law to support accusations of crime or civil action, right? And this is a listing here that I'm including, but it's actually not limited to just this, right? So examples of these civil actions or even crimes are extortion, domestic violence, fraud, that includes money laundering and theft, drug-related crimes, murder and acts of violence, pedophilia and cyber stalking, sabotage and terrorism, and of course the list goes on and on, right? So usually criminal investigations and prosecutions involve government agencies that work within the framework of the criminal law, right? So cybersecurity forensics practitioners are expected to provide evidence that may help the court make their decision in the investigated case, right? So also practitioners must constantly be aware and comply with regulations and laws during the case examination and also the evidence presentation as well, right? So now it is important to know that the factors that may be detrimental to the disclosure of evidence, that will actually challenge the validity of that evidence, right? So if anything actually change in the evidence per se, of course it may not be able to actually be presented in court. Now, digital forensic evidence is information in digital form found in a huge range of endpoint, server, and network devices, right? And basically, digital evidence is any information that can be processed by a computing device or stored in any media, right? Digital media. So evidence, tender in legal cases, includes, things like criminal trials, like we mentioned before, or cyber attacks or a breach. All this evidence is actually classified as witness testimony or direct evidence. There's also another category of indirect evidence in the forms of an object, such as a physical document, the property owned by persons, and so forth. Cybersecurity forensics evidence can take many forms depending on the conditions of each case and the devices from where that evidence was actually collected. There are three general types of evidence, right? So the first one is best evidence, the second one is corroborating evidence, and the third one is indirect or circumstantial evidence, right? So historically, the term best evidence refers to the evidence that can be presented in a court of law in the original form. However, of course, in cyber forensics, digital photography, and things like copier machines, computer storage, cloud storage, you may ask, so what is actually the original, right? So typically properly collected system images, and appropriate copies of files can be used in court in that case, right? So again, that's one of the differences whenever we actually refer to or historically referred to best evidence, right? So in this case, the original form can be, of course, a properly collected copy of that original evidence, right? So a system image, for example. Now, corroborating evidence or corroboration is evidence that tends to support a theory or an assumption, deduced from some initial evidence, right? So this corroborating evidence, it confirms the proposition in the law, in the court of law, right? So now indirect or circumstantial evidence relies on an extrapolation to a conclusion of fact. That includes, things like a fingerprint, right? Or DNA evidence collected from, a subject, right? Now, this, of course, is actually a lot different than direct evidence, right? So direct evidence supports the truth of a proclamation without the need of additional evidence or interpretation, right? So forensic evidence provided by an expert witness is typically considered as circumstantial evidence, right? So indirect or circumstantial evidence is actually often used in a civil or criminal cases, lacking of direct evidence, right? So if you don't have direct evidence, you may actually, recur to indirect or circumstantial evidence, right? So detailed information stored in electronic database, in audit logs that are, of course, computer generated and that does not contain information generated by humans, has been challenged in the past, right? In some court trials, right? So law enforcement and courts can also demand proof that the creation and also the storage of evidence records are actually part of the organization's business activities, right? So that is actually very important. And throughout, this course, you will learn how to handle digital evidence, which is actually really important that you preserve the evidence to be, valid in a court of law.